Okay, in 3.4, chemical senses, describe taste and smell processes, including the specific nature of energy transduction, relevant anatomical structures, and specialized pathways in the brain for each one of the senses. So taste. How is it that we taste? Taste is known as gustation. This is where chemicals dissolve in your mouth. Individuals are known as soup tasters, people who have particularly dense papillae, I can't remember that, filled tongues, meaning tends to be genetic. So they are very sensitive to spices. They also tend to think things taste very bitter. Your taste buds are your sensory receptors. This is where the information is transmitted. You have sweet, sour, salty, bitter, and umami, which is like the MSG, meaty, brothy flavors. Taste and smell go together, which is why I put them together. They're very much correlated, and that is called olfaction, the smell chemical sense. There are 5 million olfactory receptors in the top of each nasal cavity, which is why you guys have such strong senses of smells. And these receptors send information to the olfactory bulbs. Now remember, every single sensation goes through the thalamus except smell. Smell does not go through the thalamus. Smell goes through what we call olfactory bulbs, or like little matchsticks that are just above your nasal cavity. Our touch, our somatic senses. You have your touch, temp, pressure, and pain. Gate control theory is how you control pain. And if you take a look over here to the left-hand side, this image kind of helps, right? So it happens in the spinal cord. In your spinal cord, you have small nerve fibers. Everybody has them. They're called substance P. These small nerve fibers, so neurons, essentially is what they are, pass along substance P, which helps your body understand if it's in pain. However, in your spinal cord, you also have what we call large nerve fibers that send all the other messages. So you have one specifically for pain, and then you have the other ones for everything else. So when you get hurt, your quote-unquote gate opens, and these small nerve fibers start to send out substance P, so you know you are in pain. So you have the ability to quote-unquote close that gate, at least temporarily to some extent, by the use of what we call endorphins. Endorphins end up using the large nerve fibers in the spinal cord to send other messages to quote-unquote close the gate. This is why you might jump up and down if you stub your toe, or grab your toe if you stub your toe and rub at it. It's because sending those other messages help reduce the sensation of pain. Another sense is your kinesthetic sense. This is your body's position in space. If I asked you to close your eyes and clap your hands, you could do that because of your kinesthetic senses. And you have these photoreceptors in your skin, your joints, your muscles, and your tendons, so you know where everything is at. Vestibular is your sense of balance. This is why ballerinas can dance so well. And your sense of balance actually comes from your semicircular canals and vestibular sacs, which are all in the inner ear. So your sense of balance comes from your inner ear. This is why if you ever have an ear infection, you may feel dizzy. And that is it.